Hello everyone, welcome back to the channel. Here is VanAmsen. Today we are tackling a fascinating coding problem from the world of trees and palindrome problem 2791. Count paths that can form a palindrome in a tree. Sounds intriguing, right? So without any further ado, let's jump right in. The task here is to find the number of pairs of nodes in a tree such that the character assigned to the edges on the path form one node to another, can be rearranged to form a palindrome. So let's visualize it with a simple example. So here is an example. And for instance, if we have a tree like this, and the edges character are A, C, A, A, B, C, the valid form palindrome would be 0, 1, 0, 2, 1, 3, 1, 4, 2, 5, 2, 3, 1, 5, and 3, 5. So, sounds like a fun, challenging problem. So let's tackle this using Python. So, and make use of a bit manipulation and depth first search DFS. So we will be calling our class solution. So it's already defined, and begin by defining our main function count palindrome path. So we start by initializing our result res to 0, and this will keep track of the total number of paths that can form a palindrome. And we'll also initialize an empty dictionary count, which will keep track of frequency of each character in the path from the root node to inode. So let's implement it. And will be len of parent, dp will be 0 times n, result will be 0, and count will be default dict int. And for I in range n, mask will be self bit of dp parent si, and v count mask, and for j in mask 26 for 26th letter, result count mask XOR bit j, and result plus v and count plus 1, and finally we return result. And here is a helper function, bit self dp parent si. So yeah, so let's go with first example. So next we loop over each node in a tree, and for each node we calculate a bit mask that represents the character frequency of the path from the root node to the current node. And for each lowercase English letters, we add the count of paths that can be merged with the current path to form a palindrome to our result. And our helper function, bit, is where the magic happens. So this function uses a recursion and bit manipulation to calculate the bit mask for each path. And finally, after we have looped through all nodes and calculate the number of palindrome paths, we return our result. So let's finish our bit function. So if I0 and dp 0, and now dp I will be self of bit dp parent s parent I XOR 1 ort s minus ort a. Okay, and return dp at I. Okay, so this is our implementation, and yeah, so that's it, and there we have it. So let's run our implementation to verify it's working, because it's a hard problem, but yeah, all works perfectly, and we have yeah, output of 8 as expected. So now we can also run it for unseen test cases to verify everything's work. So I'm running it, and hopefully it will pass. Yeah. Okay, so we have successfully solved it. We beat 46% with respect to runtime, and also 55% with respect to memory. So all good. And there you have it. That's how you solve problem 2791 using bit manipulation and DFS. And remember, practice is the key when it comes to this problem, and keep coding, keep improving, and we will see you in the next video.